So this is problem 12.1. We've got a foundation. It's in three different configurations. So part A is a 1 by 1 meter squares. Part B is a circular footing. C is a 1 meter strip footing. We've got D sub F is 1 meter, and the water table is well below the bottom of the foundation. The factor of safety is equal to 3. So we want to compute the bearing capacity using Terzagh's general shear failure theory. So again, we're using MathCAD, so I just use my snipping tool, and I cut and paste this from the book, and then I start adding the variables in. So again, there are a couple of ways to add these Greek letters. You can type in, go to symbols and pick out one. The way I like to do it is to just use the keyboard. So if I wanted to type in phi, I would type in F Control G, and that converts it to phi. Eta is H Control G, and that gives me eta. So these formulas are found in your book. These are formulas 12.7 in the book. They're on page 489. So I programmed in MathCAD. Here's the eta value, here's the alpha sub theta. E is found by going to constants and typing in the E value, which is logarithm, base E, natural logarithm. So NQ is A theta squared, 2 cosine 45 plus phi over 2. In MathCAD, you can't do the square in between the parentheses and the S. You have to do it afterwards. So that gives you the square. So C is NQ minus 1 times the cotangent of phi, and then N gamma, it's complicated, so I just typed it in by picking it off of the chart. So in the square footing, I've got 1 meter by 1 meter. Q sub U is found by using equation 12.8 and 490. So I've got 1.3 C, N sub C, C is 0, so that all drops out. I've got gamma prime df N sub Q. Again, df is the distance from the top of the ground to the bottom of the footing. 0.4 gamma prime, which is given in the problem. So B is the width of the foundation. It's 1 meter. N gamma is as given, so that gives me 1,000 kilopascals. To find the net bearing capacity, I subtract the ultimate minus the weight of the foundation, which is found from the unit weight. Here, gamma prime and gamma moist are the same. Actually, let me fix that. That's not exactly right. So gamma prime, since the water level is really far down, it's really just gamma moist. Let me fix all this. There we go. So really the numbers doesn't change. Now it's just the nomenclature's right. So I get basically 1,000 kilopascals. The net divided by a factor of safety is 344 kilopascals. All right, for the circular footing, we've got the same problem going on here. I need to delete all these little primes, so I just put my cursor there and click delete. Now I've got the right numbers. So circular footing, you just use a different equation. Everything else is the same. Strip footing, likewise. So the circular footing, the net bearing capacity is 309 kilopascals, and for the strip footing, it is 370 kilopascals. That's the end of the first one.